welcome today. I am Desmond Udagese, and I'm here to take you on your favorite subject, mathematics. Today, we'll be looking at a very interesting topic. The theme of our topic for today is basic operations. And under basic operations, as a sub-theme, we have derived operations. Now, our topic is addition, subtraction, and multiplication of binary numbers. Earlier, we learned in our class on whole numbers what binary numbers are. In fact, we learned all about number bases. Well, in this class, we'll be going further to learn how to add, subtract, and multiply binary numbers. I'm sure you remember that binary numbers are also called base 2 numbers. Let's go on to learn about our topic today. Now, in the course of our class, we expect to learn quite a lot. Let's take a look at some of the things we will be learning about today. We'll do a brief recap because I'm sure you already know what binary numbers are, but we'll look at it again just to remind ourselves. We'll also learn how to count in binary numbers. This is something we've also treated, but we'll take another quick peep at it. Then we'll delve into our class to learn how to add with binary numbers. We'll also learn how to subtract with binary numbers. And finally, we'll learn how to carry out multiplication, making use of binary numbers. Now, binary numbers. Very interesting number system. The binary number system is a special way we count things by making use of only 2 digits. Now, when we say digits, what exactly do we mean? A digit is a single symbol. It's a symbol that we use to make numbers. Symbols that we use to count the number of things that we have with us. Now, the symbols are symbols that we are used to. So we have gotten used to them. Those symbols are 1. This symbol stands for the number 1. Of course, we know 2, we know 3, we know 4, we know 5, we know 6, we know 7, we know 8, we know 9, and we know 0. These are all unique symbols, okay, that we make use of in our everyday life. Now, these digits, okay, that we just counted, there are 10 of them. These digits are used in a number system called the decimal number system. The decimal number system has 10 digits, 10 unique digits from 1 to 9, and then we have 0, okay? But in the binary number system, it's quite different from the decimal number systems that we know, where we have those from 0 and then we have 1 to 9. The binary number system has just 2 digits. So instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 digits, we have just 0 and 1. We have just 0 and 1. Remember, the binary number system is also called the base 2 number system because it has just 2 digits. So we call it the base 2. Those digits are 0 and 1, like we said earlier. All other numbers that you are used to in the decimal number system that this world or civilization presently makes use of, like from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. All of these other numbers are represented in our binary number system, making use of just zeros and 1. For example, we have 1, 1, 0, 1, base 2. We write the base at the bottom of our number. So this 2 here, which is at the bottom of our number, 1, 1, 0, 1, tells us that this whole number here is a binary number, or it's a base 2 number. Now this, if we were to write this using the decimal number system that we are used to, that number is 13. So all of this represents 13. So again, like we said, all other numbers are represented in the binary number system, making use of just 2 digits, zeros and ones. So we have our binary numbers made up of zeros and ones. Now we'll go on to know how to count in the binary number system. But before we learn about that, let's quickly take a recap. I'm sure you know about it, but let's see how it explains how the binary system also works. The decimal number system that has 10 unique digits. We count starting from 0. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? When you get to 9, take note, we've gone through all of our 10 digits. Now we need to end it with the next number that comes and then begin afresh to count again. So when we get to 9, what happens is we say 10. But 10 is not a unique number in the decimal number system. We have just 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. What 10 means is that the 0, we put down 0, telling us that we've gone through a full circle. We've counted with all our digits. Now we start another one, and that's why we put 1 there. 1 tells us that we've gone round our digits, so we say 10. And then we begin the next set of our numbers with 11, 12, and so on. When we get to 19, again, we've gone around our digits, and then we put down 0, and then we say 2. The 2 tells us that we've gone around our digits twice, so we have the number 20. 10 and 20 and 30 and so on are not unique digits. We have just 0 and 9 as our unique digits. Now, let's look at the binary number system. In the binary number system, just like we saw in the decimal number system, we start at 0 and then the next digit is 1. We have gone through all of the possible digits in the binary number system. So we are starting to count afresh. What do? We write down 0. And then we put 1, telling us that we've gone round our count 1 time. Okay? The next number, we add 1, it gives us 11. We don't call it 11, it gives us 1 and 1. And then our next number, okay, if we add 1 to it, okay, we'll find that our 1 and 1, okay, gives us a full circle. So we put down 0, take 1 over, like we do in our additions in the decimal number system. Again, we'll find that it's a full circle. We'll put down 0, and then we take 1 over. So after 1 and 1, the next number we have is 1, 0, 0. We add 1 to our 1, 0, 0, and it becomes 1, 0, 1, and so on. That is how counting is done in the binary number system. All right? Now that we've seen how counting is done, let's see if we can add numbers in the binary number system. To add numbers in binary numbers, what do? We start from the least significant bit. That is, we begin from the rightmost side and then we move towards the left. It's just the same way we add numbers in the decimal number system when we use our hundreds, tens, and units. There are 4 simple steps in binary addition. Take note, 0 added to 0 will always give us a 0. 0 added to 1 will give us a 1. 1 added to 0 will give us 1. 1 added to 1, okay, just like we explained earlier, will give us a 0, and then we carry 1 over to the next significant bit. Whenever 1 is added to 1, what happens? It has completed that circle. So we put down 0, and we carry 1 over to the next significant bit. Now we'll carry out some examples so that we better understand how to add using binary numbers. If we were asked to find the sum of these base 2 numbers, 1011 base 2 plus 1001 base 2, how do we go about adding them up? Before we go ahead, to remind ourselves of that quick rules, the 4 rules that we just saw, we can quickly write somewhere here. That's our operation, plus. So we have 0 and 1, 0 and 1. We said 0 plus 0 will give us 0. 0 and 1 will give us 1. 1 and 0 will give us 1. 1 plus 1 will give us 10. That is, we put 0 down and we carry over 1 to the next significant bit. So you can quickly draw this somewhere to remind yourself of our rules. Now, from our rules, let's see how we can do our addition. So we have 1 and 1. Okay? What do? Remember we said this will be what? 0 will be our answer, and then we'll carry 1 over to the next significant bit. Again, we have 1 there, so when we add 1, 1 and 1 will also give us a 0 down, and we need to carry 1 again to the next significant bit. 0 and 0 is 0, so we drop our 1 down. Next, we have 1 and 1 again. What do? We put down 0 and carry 1 over to the next significant bit. And there we have our 1. So our answer is 10100 base 2. Let's take another example. Find the sum of these binary numbers. 1010 base 2 plus 1011 base 2. Again, 0 plus 1 is 1 in base 2. 1 plus 1, what do? We put down 0. We've come a full circle. And then we are carrying 1 over to the next significant bit. 0 plus 0 is 0, and then plus that our 1. We put down our 1. Next, again, we have 1 and 1, which gives us 0 for an answer. Because we've come through a full circle, we drop 0 down, and we carry 1 over to the next significant bit. So we drop our 1 down. Our answer becomes 10101 base 2. So that's how we add using binary numbers. Next, we'll be looking at how to subtract using binary numbers. Now, to subtract numbers in the binary number system, what do? We start from the least significant bit. From the rightmost side, we move to the left. And there are 4 steps in binary subtraction. Okay, so the 4 steps are 0 minus 0 will always give you 0. 0 minus 1 will give you 1. Take note here that, okay, you are borrowing 1 from the next more significant bit. So you borrow 1. 1 is borrowed. 0 minus 1 will give you 1 in the binary number system. 1 minus 0 will give you 1, and 1 minus 1 will always give you 0. So let's remember that rule. Let's try to answer these 2 questions. Subtract the following base 2 numbers, 1101 base 2 minus 0010 base 2. Again, just as a tip, before you start, you can quickly jot down the rule somewhere so that you remember. Our operation is minus. We have 0 and 1. We have 0 and 1. 0 minus 0, we said is 0. 0 minus 1, we said is 1. And remember, in this point, we are borrowing. You're not carrying over. You are borrowing from the more significant bit that is on your left-hand side. Also, 1 minus 0 is 1. 1 minus 1 is 0. So these are our rules. You can quickly put down somewhere so we don't forget. So let's go ahead to do our subtraction. 1101 base 2 minus 0010 base 2. 1 minus 0 is 1. 0 minus 1. Okay? We'll need to borrow from the most significant bit over here. We borrow 1. Okay? And that's why we have 0 minus 1 to give us 1. When we bring 1 down here, we have a full circle. So the full circle minus 1 gives us 1. When we subtract or we borrow from our 1 here, we have 0 left. So 0 minus 0 gives us 0. Then we have 1 minus 0 gives us 1. So we have 1011 base 2 as our answer. Hope we are following. Okay? Now we'll try the second question. Subtract the following base 2 numbers. 11001 base 2 minus 10111 base 2. Let's go ahead to do our subtraction. 1 minus 1 gives us 0. 0 minus 1, we said, will give us 1. But remember, to do that, we need to borrow 1 from the more significant bit. Okay? So we have next 0 minus 1 will always give us 1. Remember, 0 minus 1 in the binary number system will give us 1. But for us to carry out our subtraction here, we need to borrow also from this more significant bit. Okay, so we borrowed 1, and that's why we had that 0 minus 1 to give us 1. 1 is what we have in this subtraction here. But remember now, we borrowed that 1 again, and we used it here. So therefore, 1 minus 1 will give us 0. That's why we have this 0. Hope we are following. Or do we need to go over it again? Let's go over it again. We said 0 minus 1 will always give us 1. But to do that, you need to borrow from the most significant bit. So we borrowed from our most significant bit here. We already put down that value. 0 minus 1 is 1. Now, before we borrowed, 0 minus 1 here gave us 1. But to do that, we had to borrow from here. So if 0 minus 1 is 1, that was the value. And then to carry out our operation on this column, we had to borrow that 1. So that 1 that was down here has been borrowed. And now what we have left is 1 minus 1, 0. That's why we have this 0. I hope we're clear. All right? Our 1 here has been borrowed, okay, for the operation in the next column. So we have 0 left. 0 minus 0 gives us 0. And 1 minus 1 gives us 0. So our final answer is 00010 base 2. Next, we'll be looking at how we multiply numbers in the binary number system. To multiply numbers in the binary number system, start from the least significant bit, that is from the rightmost side, and then you move to the left. There are 4 very simple steps in binary multiplication. 0 times 0 is 0, 1 times 0 is 0, 0 times 1 is 0, and 1 times 1 is 1. In this case, there is no carry over or borrowing at all in binary multiplication. So we'll carry out some examples. Example 1, multiply the following base 2 numbers. We have 1101 multiplied by 011 base 2. So let's go ahead. 1101 base 2 times 011 base 2. In our operation proper, the 0 is there before our 1 and 1. It's not necessarily written down. It won't affect our operation so much more than if it is within our number itself. It's outside of our number, so we leave it out in the proper calculation. Let's go ahead to do our calculation. We have 1 multiplying 1101, basically. All of our row there becomes 1101. We also have 1 multiplying that. We are writing in the next, okay, the next row, and we are shifting it to the left. If we remember how we carry out long multiplication. Okay, so we shift that. And then we place our 0 here. This 0 here is called a place value. Place value 0. We use it to fill the space. So 1 times 1101 is 1101. Written 1 step forward beneath our first calculations. Now we'll go ahead to add our 2 rows. 1 and 0, 0 being our place value there, from binary addition that we already learnt about. 1 and 0 is 1. 0 and 1 is 1. 1 and 0 is 1. 1 and 1 is what? 0. So 1 plus 1 will give us 0. And then what do? We carry 1 over to the next significant bit. And there we have 1. So therefore, 1 and 1 again will give us 0. And we need to carry 1 over to the next significant bit. We finally drop our 1 down. So our number becomes 100111 base 2. 1101 base 2 times 011 base 2 will give us 100,111 base 2. Now let's take another example. Multiply the following base 2 numbers. 1011 base 2 times 010 base 2. So we arrange that. Again, we said our 0 here, okay, in our calculation may not necessarily be written down, as it will not be of much effect in the calculation. All right, so we write that down, 1010 base 2 times 10 base 2. 0 multiplies 1010. We have all of that in that row, brings 0, 0, 0, 0. 1 multiplies 1010, okay, and we write that down. The 0 here is our place value 0. We just use it to fill our space, okay? We've already gone far, but let's quickly remind ourselves of our rules again. We said try to draw something to remind yourself of the rules. We said 0 and 0 gives you 0, 0 and 1 gives you 0, 1 and 0 gives you 0, 1 and 1 gives you 1. So there's our rules. We said for binary multiplication, the carryover rule and the borrowing rule does not, okay, have any effect here. So therefore now we carry out our addition. We have our two rows. 0 and 0 gives us 0, 0 and 0 gives us 0, 0 and 1 gives us 1, 0 and 0 gives us 0, 0 and 1 gives us 1. So our answer simply becomes 10100 base 2. Wow, it has been quite an interesting class. We've come to the end of our class today. I will take a quick recap as what we learned about operations in binary system, talking about multiplication, addition, and subtraction. First, let's remind ourselves what we said the binary number system is. We said the binary number system is also called the base 2 number system. It's a special way of counting things by making use of only 2 digits, 0 and 1. We said digits are symbols that represent numbers. We said also that in the decimal number system, which we use in our day-to-day life, we have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 digits. But in the binary number system, we have just 2 digits, zeros and ones. We said all other numbers that we are used to can be represented by these 2 digits alone. Just as a piece of information, the binary number system is very important. You might be asking, why do we need to learn about this? In the computer world, the binary number system is what makes our computer interactive. Is how calculations or how things are programmed in the computer system that you know about. So that's one important reason why you need to know the binary number system. Operations such as addition, subtraction, and multiplication can be carried out using the binary number systems. We looked at the steps. Let's remind ourselves of the steps. For addition, we said follow these 4 steps. 0 plus 0 gives us 0. 0 plus 1 gives us 1. 1 plus 0 gives us 1. 1 plus 1 gives us 0. It actually gives us 10, but what we write down is the 0. The 1 is carried over to the next significant bit. Okay? We said also steps for subtraction in the binary system. 0 minus 0 gives us 0. 0 minus 1 gives us 1. 1 minus 0 gives us 0. 1 minus 1 gives us 0. One special step was 0 minus 1. 0 minus 1 gives us 1. But to get that value of 1, we need to borrow 1 from the next more significant bit. And finally, we talked about the steps in binary multiplication. We said 0 times 0 gives 0. 1 times 0 gives 0. 0 times 1 gives 0. 1 times 1 gives 1. We said the rules of carrying over or borrowing does not follow in binary multiplication. Now, before we go, just to confirm that indeed we've learned quite a lot, we'll do 2 quick questions and then we'll be done in our class. Let's take our first question. Bring out your pens, bring out your papers and let's solve together. Find the sum of the binary numbers 1, 1, 0, 1, 0 base 2 and 1, 0, 1, 0, 0 base 2. From our rules, okay, we say quickly write them down somewhere like this so that we don't forget them. We say 0 plus 0 will give us 0, 0 plus 1 will give us 1, 1 plus 0 will give us 0, 1 plus 1 will give us 10. 0 being written down, okay, and 1 carried over to the next significant bit. So we go ahead to add. We say 0 and 0 gives us 0. 1 and 0 gives us 1. 0 and 1 gives us 1. 1 plus 0 gives us 1. 1 plus 1 gives us 0. The other 1 is carried over to the next significant bit. So we put 1 down there. And that gives us our answer. 1, 0, 1, 1, 1, 0 base 2. So which of our options has the correct answer? Is it A, B, C, or D? Option C is correct. 1, 0, 1, 1, 1, 0 base 2. Question 2. Subtract these binary numbers. 1, 1, 0, 1, 0 base 2. And 1, 0, 1, 0, 1 base 2. So we are subtracting 1, 0, 1, 0, 1 base 2 from 1, 1, 0, 1, 0 base 2. Okay? Again, let's remind ourselves of the rules. Just write that somewhere. We have our operator minus 0 and 1, 0 and 1. We say 0 minus 0 will always give us 0. 0 minus 1 will give us 1. Okay? And we will need to borrow from the next more significant bit. 1 minus 0 is 1. 1 minus 1 is 0. Okay, so we have our rules to remind us. Let's go ahead to subtract. 0 minus 1 will give us the value 1. But to get this value, we need to borrow. Okay? So we need to borrow our 1 from there. So next column, we have 0 left because this 1 has been lent to the other column. 0 minus 0 will give us 0. 0 minus 1 again will give us 1. But to get that value, we need to also borrow 1 from the more significant column. Okay? So our 1 here has been borrowed out. Therefore, we have 0 left. 0 minus 0 gives us 0. 1 minus 1 gives us 0. So that is our answer. 0, 0, 1, 0, 1 base 2. Let's see which of our options is correct. Is it A, B, C, or D? Option B is correct. 0, 0, 1, 0, 1 base 2. We've come to the end of our class for today. I'm sure you've learned quite a lot. To remember all that you've learned, I urge you to keep practicing, practicing, and practicing. Till I see you in the next class, I am Desmond Edagise. Bye-bye. Till then.
If you enjoyed this video, hit the like button, drop a comment, and subscribe to our channel. You can also turn on notifications to stay updated on new videos on this channel. This Brain Friend video was brought to you by Synforest. For more of these amazing e-learning videos, get your copy of Brain Friend. With more than 1,000 e-learning videos, over 74,000 test items in more than 40 subjects, a career counseling guide, and many other amazing features, BrainFriend remains your foremost e-learning and exam preparatory software. BrainFriend. Learn better, make excellent grades.